A thin semicircular conducting ring PQR R of radius R is falling with a plane vertical in a horizontal magnetic field B. Magnetic field is B here. This is the entire magnetic field here, as shown in the figure. The potential difference developed across the ring when its speed is B is what we need to find. Okay, here we know that the motional EMF induced in the semicircular ring PQR is equal to the motional EMF induced in the imaginary conductor PR. That means imaginary conductor P and R here. So, in mathematically, we can write this one as, that is, epsilon into PQR, which is equal to epsilon into PR. Then we can write this one as B times BL, which is equal to BV into 2 times of R, because L is nothing but the L is equal to PR, then PR is nothing but 2 times of R. Then we can say the potential difference developed across the ring, that is 2R BV, where R at the higher potential, or at the higher potential, higher potential. This we can see in the option. R is at higher potential, R is at point means, and at 2R BV. So option D is the right answer.